Hi everyone. Um, Today we're going to take a look at a little bit of an extension of what we've been doing, and this is going to be from chapter 9, and it is called function notation. For our warm-up today, let's look at this relation. Remember, our relation is a set of ordered pairs, so I have 3 ordered pairs in this relation, and I'm telling you it's not a function. Can we remember why? Well, remember, a function is when each input has exactly one output. And I really like using the mapping diagrams to help us. So our inputs are -6 and -8, and our outputs are 16 and 12. And then we can go ahead and draw our arrows. So -8 maps to 16, -6 maps to 16, and -6 also maps to 12. So if we look at this, the input -6 has 2 outputs. So it's not a function because -6 has 2 outputs. And so which point can we change? Well, we can change one of those. As long as we change the input value, we're going to be fine. So I would want to change the -6 in one of these 2 points. It doesn't really matter. So like if I made this -7, 16, then this would turn into a function. It's actually okay that we have a repeated output. We just can't have a repeated input. So let me make a second mapping diagram. Don't have a ton of space, but let's squeeze that in there. So if we change that input for this point to -7, we would have -6, -7, -8, and our outputs would still be 12 and 16. And again, -8 maps to 16, -7 maps to 16, and -6 maps to 12. And this is a function because each input has exactly one output. So we've been working a lot with functions, linear equations, and relations. And we did a lot of this in chapter 2. And one of the things that we really focused on was linear equations, especially in chapter 8. And linear equations can be written in the form y equals mx plus b. This is our slope-intercept form. And it allows us to see the exact mathematical relationship between the input and the output. So remember, we put the x in, we do the math, and we get the y. For this function notation, we're going to kind of keep this same form, except we're going to take the y and we are going to replace it with this little notation here, an f, and then in parentheses, an x. And this is called function notation. And we say it f of x. There's a specific form like that we use with these parentheses, and there's a specific way we say this. It's not like f times x or fx. It's f of x. And what we mean is, right, the f is a function of x. And so really all we're doing here is replacing the y with this new notation f of x. So let's pretend our rule was y equals 2x, and all of a sudden now we're just going to replace it with f of x equals 2x. Now you might ask yourself, well, why are we doing that, Mrs. T? What's the point here? Glad you asked. What this does is this allows us to see the input and the output at the same time. Okay, so let me show you how this works, and we'll do a couple together, and then I'm going to have you do some on your own. So let's pretend, or let's say we have this g of x equals 3x minus 1. Again, this is our output. The g of x is the output. It's the y. And our input is the x. So when we write g of 3, if you notice, this is where the x was. And so what we're going to do is we're going to replace our x with 3. So we write g of 3 equals 3 times 3 minus 1. Again, it was 3x minus 1, so I replaced the x with 3. Now I'm just going to use my PEMDAS, 9 minus 1, and that is 8. And g of 3 equals 8. So the cool thing here is that we now know both the input, 3, and the output, 8, for this particular function. And this actually gives us, again, the ordered pair, 3, 8. And that ordered pair, 3, 8, is a solution to the equation y equals 3x minus 1, g of x equals 3x minus 1. It just is a little bit more convenient because if I just wrote y equals 8, you wouldn't know what the input was there. You would know the output, the y, but you would be missing the input. All right, let's do this again. So g of negative 1, again, we're going to replace the x in 3x minus 1. We're going to replace that with negative 1. We're going to do the math and get our output. So g of negative 1 is negative 4. And again, g of 5 is 3 times 5 minus 1. G of 5 is 14. A lot of times when we use this function notation, we kind of use g of x, f of x, and h of x. Those are the really common ones that you see. So let's do a couple more, just with a new one, just to get the idea here. We're going to have h of x be 2x minus 4. So what is h of 0? It's 2 times 0 minus 4. H of 0 is negative 4. What's h of 10? Again, replace that x with whatever's in that parentheses. H of 10 is 16. And h of negative 6. So sometimes I use the parentheses for times, sometimes I use a dot. And this is just a nice review of our integers as well. And h of negative 6 is negative 16. All right, so let's look at one more example here. If f of x is negative 4x plus 3, does the ordered pair belong in the function? So what we're saying is this a solution, right? And a solution is a value that makes the statement true. And when we write the point 3, 2, again, this is our input. Our x is the first value. Our output, our y, is the second value. But remember, because we're using function notation, the y and f of x are interchangeable. So in our function notation here, we're going to replace the entire f of x part with the 2. And then the x, the input, with the 3. And again, I'm going to put a question mark here because I don't know. Negative 4 times 3 is negative 12. And 2 does not equal negative 9, so no. 3, 2 does not belong, does not belong in the function because it doesn't make the equation true. All right, so I'm going to ask you to do the rest of these on your own for homework. And let me just go through the directions so that you understand what's happening. So for questions 4, 5, and 6, I want you to determine if the ordered pair 0, 5 belongs to the function. So again, 0 will be the x or the input, 5 will be the f of x or the h of x, the output. And I want to see your math there. For 7 and 8, okay, you are given a graph or a table, and you're going to write the function rule f of x equals mx plus b. So this is just our classic slope-intercept form, right? So you need to find the slope and the y-intercept. And I want you to think about what that means from the table. Remember, the y-intercept is when the graph crosses the y-axis, and the x value is 0 for the y-intercept. Once you do that, then I want you to find the output when the f, or the input value, excuse me, is 3. So I want you to find f of 3. And the last one is a word problem. And again, we're just going to be using the same y equals mx plus b notation. A baby weighs 8 pounds at birth, and she gains 1.2 pounds each month during her first year of life. Write this as a function rule. Y is f of x equals mx plus b. Find f of 10. Again, this would be your input. And interpret what this means. And what I mean by that is like using the words in terms of what's happening in the problem. Remember, you do need to define your variables here. So you should have a let statement for what x represents and a let statement for what f of x or y represents. So try these. We will go over them at our next class. And great job just wrapping up the content this year.